All right, so we've gone through what the symbols mean. Let's start applying and making maybe some more meaning out of these symbols. There we go. So linear inequalities. Let's look at some number line graphs. So let's erase those. So number line graphs. Number line graphs. So we're really just going to be looking at sort of one-dimensional number lines. We're not going to be doing perpendicular number lines and labeling them x and y. We're just going to be doing single one-dimensional number lines. So for example, this is what a number line looks like. Typically we start with 0 in the middle and we can go to the right by 1, 2, 3, 4. So really as we move to the right we are going into larger number territory, or instead of going to the right from 0 we could go to the left, right? We could go to the left from 0 and then we would get into smaller number territory. So really if we are looking at two numbers here, let's say I have -2 right here, so -2, and then let's say I have 3 right here, 3. Well, 3 is more to the right than -2 on this number line. What that means is that 3 is larger than -2. So we would draw the inequality symbol with the sort of alligator teeth, facing the larger number. So really, this inequality symbol, it really opens up towards the larger number. What does that mean? Well, the inequality symbol opens up towards the number that appears further to the right on the number line. So let's look more generally here. Maybe I'll erase that. There we go. Okay, so let's zoom in. There we go. Please don't crash on me. There we go. Okay, so let's look at another. Let's look at another number line. I don't know what's happening here. Oh dear. Okay, maybe I'll just change colors because I want it to be further away from the statement. So I will change colors just to make it seem like we are in new territory here. So a new number line graph. Let's say we in each of these cases we're going to be dealing with two numbers a and b. Now for the purposes of this explanation, I don't know what a is and I don't know what b is, but I'll show you the relationship between them on these number line graphs. So let's say I have a here, and let's say I have b here. So number A is here, number B is here. I don't know if A is positive or negative, or is A 0? Who knows? I don't. Nobody knows. Actually, if this is all the information that you have, nobody really knows. But what we do know is that B, number B, is further to the right than A. So if B is larger, right, numbers to the right are larger, numbers to the left are smaller. So what can we say about the relationship? What can we say about the relationship between A and B? Well, we can say that B is just larger than A. So that is a typical number line graph that we would draw. Now let's do a new one, maybe in a new color. So let's try some green. Now let's say we have two numbers a and b again, and we don't know what specific values they are, but let's say that b appears here and a appears here. Now I don't know if b is positive. I don't know if b is negative. Maybe b is pi. Maybe b is pi divided by 1,000,000,000. Who knows? I don't. Nobody does if this is all the information that we have. But we can state something about these two numbers if this is how they're presented on a number line. We can say that in this particular case, b is smaller. B is smaller than a. Right? We can say that for sure. And I should note, in each of these cases, you could represent this relationship in two ways, right? So let's look at this example. Here I could say that A is less than B, or here I could reverse the order. I could say B is greater than A. These are two equivalent statements. They mean the same thing. If A is less than B, that really means that B is greater than A. And additionally, in this green example, I could say that, well, B is less than A, and that's really the same thing as saying A is greater than B, right? So these are equivalent statements right here. So these are some hopefully helpful and instructive number line examples. And let's do one final number line example. It's kind of a silly one, actually. Let's do this in red. So here's another number line. And I'm actually going to show, B in black. And then I'm going to show A in blue. So A is right here, and B is also right here. They're both there. So what can we say about A and B? If they both land on the same exact spot on the number line, then we can say in this particular case, let's maybe do some space gray. If they both land on the same spot on the number line, what can we say about them? Well, they are actually equal in this silly case, right? If both of these numbers land on top of each other on the number line, they have the same value or the same size. So this is how we can represent numbers on a number line. And even if we don't know what these specific numbers are, we can at least say something about these numbers, right? In this particular case, we can say that either A is less than B, or equivalently, B is greater than A. If we don't know what A and B are here, but we know their respective or relative positions on a number line, A is further to the right, then we can say that B is definitely less than A, or in other words, A is definitely greater than B. It's an equivalent statement. And in this particular silly case, you might call this trivial, right? This is sort of a trivial case. If both of these numbers land on the same spot on the number line, they're actually equal. They are the same number. They're the same thing. So that is hopefully some instructive examples for these number lines. Now again, I'm going to make a little line break here, and I'm going to look at applying some of this knowledge. So we're going to look at graphs of inequalities with variables. So with variables. So let's see. Hey, we could ask for what is the solution? Whoa, we're usually used to seeing this word. We're usually used to seeing this word related to equations, but hey, in this particular case, we're going to be seeing this word related to inequalities. So that's exciting. So what is the solution for the following inequality with a variable? X is greater than or equal to 3. What is the solution to this? Well, let's look at a potential solution to this. What is this statement really saying? It's really saying what number could we substitute or plug in for x that would truly be greater than 3? Well, we know that the number 2 would be wrong, right? 2 is not greater than 3. We know that the number -9 would be wrong, right? -9 is definitely not greater than 3. Any negative number is actually smaller than +3. So this is not going to work. So what would a potential solution be? Let's think hard about this. What number is greater than or equal to 3? 5 is a number that's greater than or equal to 3. Hey, there we go. So you might say, hey, I found my solution. But should you stop here? No, you should not stop here. Don't stop. Don't stop. There are more solutions. There are more solutions. Okay, so let's think about what might be another solution to this. Maybe what is a number that is greater than or equal to 3? Think hard, think hard. 10. 10 is a number that is greater than or equal to 3, right? Okay, so should we stop? Should we stop? We have 2 solutions here. Should we be satisfied? No, we should not stop. We should not be satisfied because we can find another number that is greater than or equal to 3. 105, right? That is greater than or equal to 3. What is another number that is greater than or equal to 3? Well, let's see. 3 is greater than or equal to 3 because 3 is in fact equal to 3. So 3 satisfies this, right? 3 might not be greater than, but it sure is equal to 3, so that works. What might be another number? What might be another number? Maybe 3.001. Well, that is definitely true, right? 3.001 is in fact greater than 3 by just a little bit, right? By just a little bit. So this is starting to look crowded, right? Because we could also put in the number pi. Pi is greater than 3. We could also put in the number square root of 15, right? That is definitely greater than 3 because the square root of 15 is in between 3 and 4, right? Pretty close to 4, actually. So, can we think of another number? Absolutely. Absolutely, we can think of another number. In fact, how many numbers can we think of? How many numbers could we possibly think of? We could really think of an infinite amount of solutions. So there are infinite solutions. How could we write an infinite number of solutions? Here's how we do it. We do it with graphs. Okay, so what is a solution for x is greater than or equal to 3? Well, let me shrink this and make some room. So how can we write all possible solutions? How can we write all possible solutions? Well, here's my number line. Here is my number line. Let's say I have the number 0 right here, then I have 1, then I have 2, then I have 3. Well, if x is greater than or equal to 3, then I know that 3 is definitely a solution, and all numbers greater than 3 are a solution. This is just a number line graph which represents the solution to this inequality, right? 3 is represented, so we draw that with a filled in circle, and then all numbers greater than 3. So we move to the right from that point to all numbers greater than 3. So this is the number line graph solution to this particular example. Now let's change this up a bit. And I really mean just a little bit. Let's change this up a little bit. So let's say, what is the solution for, I don't know, x is greater than 3? So this is a pretty similar statement, right? The statement in black up here says greater than or equal to 3, and this statement really says, what about when x is just greater than 3? So let's do a number line solution, because really there we'll run into the same problem. 5 is greater than 3. Basically, all the solutions except for 1 will be common to both this black statement and this green statement. So let's represent this. We'll have 0 here, 1 here, 2 here, and 3 here. Now, in the previous example with the greater than or equal to, we drew a dot above the number 3, and we'll do the same thing, but this particular dot, it's not going to be filled in. It's going to be an empty circle or an empty point. Right? This point was this point in black. This point in black was filled in. This was a filled point. But in green, for x is just greater than 3, we draw with an empty circle. Why do we draw with an empty point here? Well, and then, of course, we draw all the numbers to the right of that point. I can do a straighter line than that. So we draw, so all of these numbers to the right of 3 are greater than 3, but we draw this empty point here because 3, the number 3, is actually missing from the set of solutions, right? 3 is greater than 3 is not a true statement. So because 3 simply isn't greater than 3, it's just equal to. So that's why we draw this empty point. We say that all numbers larger than 3 except for this particular value are in the set of solutions. So that's what inequalities look like, or that's what solutions for inequalities look like as graphs. It is very convenient to draw these graphs for your solutions, because you can really represent an infinite amount of numbers here. And I'm just going to fix a little bit of grammar here. It says, what is the solutions for x is greater than 3? Let's just say, what is the solution for x is greater than 3? This is the total set of all solutions for x is greater than 3. So I'll quickly do two more examples here. So what about x is less than -1? What is the I'll say solve. So solve this. So solve x is greater than -1. Solve it with a graph. Cool. So let's say 0 is right here. Let's say -1 is right here. Is -1 part of the solution set? No, -1 won't work here, because -1 is not less than -1, right? It's equal to, so that won't work. But all numbers to the left of -1 will work. So this is the graphical solution to x is less than -1. So we are solving inequalities here. This is exciting stuff. And the last inequality that we'll solve, let's do this in space gray, a beautiful color. So let's say we'll have a very similar statement to the one above. X is greater than or equal to -1. We'll solve this with a number line solution. 0 is right smack dab in the middle. We have numbers smaller than 0 to the left of it, or in other words, negative numbers happen to the left of 0. -1 is the first negative integer that we would draw there. And then what is the first solution? Well, -1 is part of the solution set, so we'll draw that with a filled in point. And then all numbers to the left of -1 are also solutions. So this is what graphical solutions look like for inequalities with variables. So hopefully that's helpful. And in the next video, what are we going to look at? In the next video, we're going to look at maybe some how to talk about inequalities with words. And it'll be important to be able to do that because sometimes you'll have word questions in your workbook and on tests and stuff like that. Okay, so I'll see you in the next video.